Hi everyone, welcome to the class. In this video, we are going to discuss important questions on the topic inverse trigonometric functions. Before we begin the chapter, let me remind you some basic terms of the chapter and some results for inverse trigonometric functions. Moreover, I would like to remind you some important substitutions to simplify trigonometric expressions involving inverse trigonometric functions. Here is our first question. Write the principal value of tan inverse 1 plus cos inverse negative 1 by 2. How will you find the principal value of this expression? So, we know that principal value. What is principal value? The value of an inverse trigonometric functions which lies in its principal value branch is called the principal value of inverse trigonometric function. For sine inverse x, what is the principal value branch? Sine inverse x, what is the principal value branch? Theta belongs to minus pi by 2 to plus pi by 2. Cos inverse x, we have the principal value branch. What is the principal value branch of cos inverse x? We have the principal value branch 0 to pi. Tan inverse x, we have the principal value branch open bracket negative pi by 2 to plus pi by 2. Okay, these are the principal value branches of sine inverse x, cos inverse x, tan inverse x. Again, there are some results to be learned like sine inverse theta, sine inverse sine theta is equal to theta for all theta belongs to minus pi by 2 to plus pi by 2. Cos inverse cos theta is equal to cos theta is equal to theta for all theta belongs to 0 to pi. Tan inverse tan theta is equal to theta for all theta belongs to minus pi by 2 to plus pi by 2. Again, this sine inverse of negative x will be substituted minus sine inverse x cos inverse, sorry, not cos, we have tan inverse negative x is equal to tan inverse negative x will be substituted minus tan inverse positive x. Again, cosec of negative x will be substituted negative cosec inverse positive x. Other three ratio inverse like cos inverse negative x is equal to pi minus cos inverse positive x. Sec inverse negative x is equal to pi minus sec inverse positive x. Then cot inverse negative x is equal to pi minus cot inverse positive x. These are some important substitutions to simplify trigonometric expressions involving inverse trigonometric functions. Let us try our first question. First question, we have tan inverse 1 plus cos inverse negative 1 by 2. Okay, we have to learn this thoroughly by heart. So we are going to take these substitutions to simplify the expression. So here tan inverse 1, we should try to apply this property. Okay, this property tan inverse tan theta is equal to theta. So 1 can be expressed. We want to make tan inverse of tan ratio 1 means tan pi by 4 is 1. So we can write, we can simplify it easily. Tan inverse tan pi by 4, we can written pi by 4. So cos inverse negative 1 by 2. Cos inverse negative 1 by 2 will be expressed like pi minus, you apply this substitution. Okay, pi minus cos inverse positive 1 by 2. So tan inverse tan pi by 4, we know that pi by 4. So pi minus, so cos 1 by 2 means we know that what is cos sin theta sin 30 1 by 2 cos 60 means pi by 3. So pi minus pi by 3. So pi by 4 plus 3 pi minus pi by 3. So we will be getting pi by 4 plus 2 pi by 3. So by taking the LCM, 3 pi plus 8 pi divided by 12. So what is our answer? Our answer is 11 pi by 12. Is it clear? Okay, this is our second question. Find the value of tan inverse root 3 minus cot inverse negative root 3. Value of tan inverse root 3 minus cot inverse negative root 3. So we apply the substitution here. Tan inverse root 3. We know that cot inverse negative means pi minus cot inverse root 3. So we are opening the bracket. Tan inverse root 3 minus pi plus cot inverse root 3. So we know that tan inverse x plus cot inverse x. This result we should learn tan inverse root 3 plus cot inverse root 3 or tan inverse x plus tan inverse x plus cot inverse x is equal to pi by 2. So we substitute for this tan inverse root 3 plus cot inverse root 3 minus pi. So this become pi by 2. Pi by 2 minus pi. So when you simplify, what will you get? Pi minus 2 pi by negative 2. Answer is negative pi by 2. Okay, let us look at our third question. Find the principal value of cos inverse. Find the principal value of cos inverse cos of negative 680. This is a trigger. Okay, cos function. Cos of negative theta, we know that. What is cos of negative theta is equal to fourth quadrant, no? It is in fourth quadrant, third quadrant. So cos of negative theta is equal to cos theta. So we can write cos inverse of cos 680. Again, we have to check whether this cos angle is lies in its principal value branch or not. No, this is not lies in its principal value branch, but it's a principal value branch of cos inverse function. Cos inverse function principal value branch is 0 to, we know that 0 to pi. This is a principal value branch of cos inverse function. So which does not lies in it. So we have to go to the proper quadrant. So 680 lies. Let us see, 680 means 180, 360, 540, 540 again 720. 720. I think this 680 lies in it. 680 lies in its which quadrant? Third quadrant. So this will be simplifying like cos inverse. Okay, it lies in its 680. Let us see, 680 divided by 360 to 720. Okay, 40. It will be minus 40. So we can write 2 pi minus cos 2 pi minus cos 2 pi means we know that 720. Okay, 720 minus 40. Okay, 720 minus 40. So cos inverse cos 720 minus 40 means cos 180 multiples. So ratio will not change. 720 minus 40 means cos 40 itself. Now we apply the property cos inverse cos 40. How much we have? Cos inverse cos 40 become 40 degree. So this degree measure we can convert to radian measure. How will you convert it? Degree measure to radian measure? Multiply by pi by 180. 0 is cut. So 2 9. So what is the answer? 2 pi by 9. This is the value of this uh, expression. Okay. Okay. Here is our fourth question. What is the principal value of cos inverse cos 2 pi by 3 plus sin inverse sin 2 pi by 3? Okay. You should remember whether the given angle lies in its principal value branch or not. Otherwise, you have to express in appropriate principal value branch. Of course, 2 pi by 3. 2 pi by 3 means what? What is 2 pi by 3? 2 pi by 3 value 2 into 180 by 3. Okay, 120. Of course, cos inverse trigonometric function, cos inverse function lies in its 0 to pi. This is lies in its principal value branch. So we can apply this property cos inverse cos theta. How much? Theta. So we use the substitution to simplify these trigonometric expressions involving inverse trigonometric functions. So, okay, this 2 pi by 3 lies in the 2 pi by 3 lies in 0 to pi. What is the principal value branch of cos inverse function 0 to pi? This is of course lies in it. So this is the value. So this 2 pi by 3 does not belong to principal value branch, but it's a sine inverse function principal value branch. Sine inverse function or sine inverse function, what is the principal value branch? We have minus pi by 2 to plus pi by 2. This does not belong to that. So we have to change to inverse. So pi minus sine inverse. What will you write? Sine inverse sine pi minus pi by 3. Sine function positive in its second quadrant. In second quadrant, sine function is positive. We know that in the first quadrant all are positive. All are positive. In second quadrant, sine positive, cosec positive. Okay, in the third quadrant we have tan positive, cot positive, fourth quadrant cos and sec positive. So we change to second quadrant. Then only we can get the solution in the principal value branch. Minus pi by 2 to plus pi by 2. So 2 pi by 3 plus sine inverse. What is sine 180 minus theta? Sine 180 minus theta sin theta. So this value pi by 3 lies in its principal value branch. So 2 pi by 3 plus what is sin inverse sin theta? Sin inverse sin theta is equal to theta. So it is answer is pi by 3. So as we have the common denominator, we will add the numerator 3 pi by 3. 3 is cut. So the value of principal value of this expression is pi. Have you got it? Okay, let us take a look at the fifth question. Find the domain of y equal to sin inverse x square minus 4. This is very important question. We have to find the domain. We know that sin inverse function domain lies between minus 1 and plus 1. Domain of sin inverse function minus 1 to plus 1. So we write minus 1 less than or equal to x square minus 4, x square minus 4 less than or equal to 1. So we added positive for both sides. X square minus 4 plus 4 less than or equal to 1 plus 4. 3 less than or equal to x square less than or equal to 5. So the x value will come lies between, we know that x square greater than or equal to 3 or x square less than or equal to 5. From the inequality we can take out x square less than or greater than or equal to 3. We know that 3 less than or equal to x square means x square greater than or equal to 3 or x square less than or equal to 5. Now, if x square greater than or equal to 3 means we know that x value lies between minus 3, x less than or equal to negative root 3 or x greater than or equal to positive root 3. When x square less than or equal to 5 means we know that what is our domain? Minus 5 root less than or equal to minus root 5 less than or equal to x less than or equal to positive root 5. Okay, let us see in the number line. We have negative root 3, negative root 5 this side, positive this side. So let us see, less than negative root 3 means domain will come this side. Less than negative root 3, greater than 3. So what is the x value? What is the x value? X belongs to negative 5, negative 5 to negative root 3 union root 3 to root 5. This is the domain. Okay, answer domain value lies in this group and in this group. So less than negative between minus negative root 5 and negative root 3, and as from the answer we understand that x greater than or equal to root 3 means answer domain will lies here and here. So remember, very important question, note it down. Okay. Okay, we will discuss sixth question. Express tan inverse cos x by 1 minus sin x. Okay, domain lies in its minus between minus 3 pi by 2 and pi by 2 in the simplest form. We have to express in simplest form this expression. we will express in simplest form. Okay, we have this is a tan inverse function. So we remember this property, tan inverse tan theta is equal to theta. We try to express the expression inside the bracket. We have to express in tan theta, like to tan theta. How can you express? Cos x can be changed. Cos x can be changed sin 90 minus x only, sin 90 minus x only, cos x. Similarly, 1 minus, here also again sin can be expressed cos 90 minus x only, sin x, sin 90 minus x, sin 90 minus theta, cos x. So what happened? What will you do? This expression now inside the bracket will change to tan theta, so that we can apply this property for simplification. So some more simplification is required. Tan inverse. Okay, we remember now sin 2x. What is sin 2x? 2 sin x cos x. Okay, numerator terms we will simplify by using this identity. We learned sin 2x equal to 2 sin x cos x. If it is sin x only, what will you write? 2 sin x by 2 cos x by 2. So in the denominator we have 1 minus cos. So do you remember what is 1 minus cos 2x? What is 1 minus cos 2x? 2 sin square x. If it is only 1 minus cos x, we have to make substitution 2 sin square x by 2. Remember this identity already we have studied, discussed in the last chapter. So 1 minus cos x, 2 sin square x by 2. Okay, so sin pi by 2 minus x can be applied. This identity means 2 sin by 2 means pi by 4 minus x by 2. Angle should be divided, when it is x, it should be divided by 2. So pi by 2 by 2, pi by 4, x by 2. Again cos pi by 4 minus x by 2. In the denominator, we apply this identity, 1 minus cos x, 2 sin square x by 2 means 2 sin square x by 2. This is x, x should be divided by 2. So pi by 2 by 2, pi by 4 minus x by 2. So 2 is cancelled, sin pi by 4, 1 is cut. So cos pi by 4 minus, so in the bracket left, cos pi by 4 minus x by 2 sin pi by 4 minus x by 2. What is cos by sin? Cos by sin is cot pi by 4 minus x by 2. So again we have to express cot in terms of tan, so that we can simplify it easily. So tan inverse cot, again we can ask what is cot x? Cot x what? We can express tan 90 minus x. Okay, tan 90, we know that tan 90 minus x, we can write cot x. So cot x can be expressed tan 90 minus x, pi by 4 minus x by 2. So we open in the bracket, let us open the bracket, tan inverse tan pi by 2 minus pi by 4 plus x by, we have x by 2. Okay, tan pi by 2 minus, so what is tan pi by 2 minus pi by 4? Tan pi by 2 minus pi by 4 means we know that pi by 4 plus x by 2. So we know easily we can substitute tan inverse of tan theta what? Theta. So what is our answer? Pi by 4 plus x by 2. Pi by 4 plus x by 2 is the answer. Is it clear? Okay, we have the next question. Express sin inverse sin x plus cos x by root 2 equal to where domain lies between minus pi by 4 and plus pi by 4 in the simplest form. So very easy question. Sin inverse sin x plus cos x by root 2. So as we have root 2 common, this give to common for both the terms in the numerator. I will write sin x by root 2 plus cos x by root 2. To simplify this expression, we are going to apply sin a plus b formula. What is sin a plus b formula? Sin a cos b plus cos a sin A cos B plus cos A sin B. Like that we can express the bracket terms. So sin inverse equal to sin x, sin A cos B can be expressed cos pi by 4. What is 1 by root 2? 1 by root 2 means cos pi by 4. Okay, cos 45 1 by root 2. Again cos x sin pi by 4 also 1 by root 2. So this expression is equal to sin A plus B. Sin A 1 by root 2 taken as it is as cos pi by 4. 1 by root 2 here sin pi by 4. Both the values we know 1 by root 2. Sin pi by 4 cos pi by 4. So sin A cos B plus cos A sin B, we know that sin A plus B. Sin inverse sin A plus B. What is A x? A x B pi by 4. So sin inverse of sin become x plus pi by 4. This is the answer. Clear? Okay, next question. Very simple and very important also. Cos of tan, solve for cos of tan inverse x equal to sin of cot inverse 3 by 4. We are given cos of tan inverse x is equal to sin of cot inverse 3 by 4. Okay, look at the equation. In the left side, we can see cos of this trigonometric inverse function. Okay, this side sine of both side. If you make a common ratio like cos, so it will be easy. It would be easy to simplify. So here we have cos, here we have sine. Sine we know how to convert to cos. Sin x can be changed like cos 90 minus x. So RHS right side we can express using this formula cos pi by 2 minus cot inverse 3 by 4. Consider this is the x. Okay, so both side cos come eliminated, so only tan inverse x will exist. Pi by 2 minus cot inverse 3 by 4. For some more simplification required. Okay, so we have to find the value of x. To get x, what we should be done? Tan inverse x plus cos inverse x we know, because already 1 pi by 2 is there in RHS. Tan inverse x plus cot inverse x, we know that what is the answer always? It will be pi by 2. That is the result property. Okay, so tan inverse x can be expressed. How will you express? Pi by 2 minus pi by 2 minus cot inverse x is equal to pi by 2 minus cot inverse 3 by 4. Both side pi by 2 is the which is cancelled. Even negative also cancelled. Cot inverse x equal to cot inverse 3 by 4. So we got both side cot inverse function. So cot inverse cancel means what is the value of x? X becomes 3 by 4. Clear? Okay, this is our ninth question. Sin inverse 4x plus sin inverse 3x equal to negative pi by 2. We know that then the total is negative pi by. So we have to solve for x. So for solving, we take this sin inverse 3x right side. Okay, sin inverse 3x shifted right side. So sin inverse 4x, we are trying to find out what is x. Sin inverse 4x. So what will be doing next step? The sin inverse will go that side. It becomes sin. Okay, sin inverse changes side. It becomes sin of minus pi by 2 minus sin inverse 3x. See, in both the term negative is there. The negative is taken common. Okay, pi by 2 plus sin inverse 3x. This negative will be taken to LHS. This negative will be taken to LHS. Sin pi by 2 plus sin inverse 3x. What is the value of sin of pi by 2 plus sin inverse 3x? Sin pi by 2 plus x means we know that it is second quadrant. Second quadrant sin will be always positive. Second quadrant sin will be positive. So minus 4x is equal to cos sin inverse 3x. To solve this one, we have to make a triangle. Sin 3x means opposite by hypotenuse. 3x by 1. Sine ratio opposite by hypotenuse. So this third side become root of 1 minus 3x square is equal to root of 1 minus 9x square. But we got the third side root of 1 minus 9x square. So we want to express in terms of cos inverse. Okay, so minus 4x is equal to cos of cos inverse. What is cos ratio? Adjacent by hypotenuse. Root of 1 minus x square by 1. So cos of cos inverse become, so cos of cos inverse become x. So it becomes, what will return? 1 minus 9x square. As we have negative in the left side, so squaring both sides. Okay, squaring both sides, minus 4x whole square root of 1 minus x square whole square. 16x square is equal to 1 minus 9x square. So minus 9x square come this side, it become plus 9x square is equal to 1, implies 25x square is equal to 1. X square 1 by 25, x become plus or minus 1 by 5. According to the questions, this answer is negative. So we cannot take the positive answer. So what is the value of x? X is equal to negative 1 by 5. From the question we know that answer is negative answer. So we avoid a positive answer and get our correct answer x equal to negative 1 by 5. Clear? Okay, we are going to discuss next 10th question. Prove that sine inverse 8 by 17 plus cos inverse 4 by 5 is equal to cot inverse 36 by 77. Okay, to solve this question, we need to prove, not like proving. Okay, proving. We have to prove cot inverse 36 by 77. To prove this, we need to do some substitution. Okay, let us assume sine inverse 8 by 17, let us assume alpha. Therefore, sine alpha is equal to 8 by 17. Like that, cos inverse 4 by 5, it is assuming by beta. So, cos beta can be written 4 by 5. So, we are going to express in cot ratio. Okay, so we need to find out what is the cos alpha and sine beta. Cos by sine only cot. So we are required to find out cos alpha what is, sine beta what. Okay, what is cos alpha? Cos alpha is equal to root of 1 minus sine square alpha. That means root of 1 minus 8 by 17 square. 289 minus 64. What is 289? Minus 289 minus 64 by 289. 225 by 289, square root of 225 by 289 is equal to 15 by 17. Now we will find out what is sine beta. Sine beta root of 1 minus cos square beta. So again 1 minus cos square beta 4 by 5 square. We know 16 by 25. 4 by 5 square means 16 by 25. When you take LCM, 25 minus 16 by 25, it is 9 by 25. We got 3 by 5. We got sine alpha value, cos alpha value, sine beta value, cos beta value. So we are required to find out what is cot alpha, cot beta. Okay, cot alpha, cot beta. What is cot alpha? Cot alpha is actually cos alpha by sine alpha. Cos by sine. Cos alpha by sine alpha. What is cos alpha? 15 by 17 by 8 by 17. It can be cut 15 by 8. Like this, what is sine alpha? Sorry, what is cos alpha? Cot beta. Cot beta required to find. Cot beta means cos beta by sine beta. Cos beta 4 by 5, sine beta 3 by 5. 4 by 5 by 3 by 5, we are getting 4 by 3. Now we have one identity. Do you remember that identity? Cot alpha plus beta is equal to cot alpha cot beta minus 1 by cot alpha plus cot beta. we have the value of cot alpha here. What is the value of cot alpha? 15 by 8 into 4 by 3 minus 15 by 8 plus 4 by 3. Okay, while simplifying 3, 5 here, cancelling 2 here, 5 by 2 minus 1 by, here what is the 45 plus 32, 45 plus 32 by 24. So 5 minus 2 by 2 by 45 plus 32 by 24. So value of cot alpha plus beta is equal to 3 by 2 by 77 by 24. While taking the reciprocal, 3 by 2 into 24 by 77. 2, it can be cancelled here 12 times. So we got 36 by 77. Okay, we should get 36 by 77. So we know that cot alpha plus beta. Cot alpha plus beta, what you got? Cot alpha plus beta. So it can be written alpha plus beta is equal to inverse cot inverse 36 by 77. This is supposed to get alpha. We are taken what is alpha? Sine inverse 8 by 17 plus, okay, we have beta. What we have taken? Beta we have taken cos inverse 4 by 5 is equal to 36 by 77. Is it clear? Okay, here is our 11th question. Prove that tan inverse root 1 plus x by minus root 1 minus x by root 1 plus x plus root 1 minus x equal to 5 by 4 minus 1 by 2 cos inverse x. This is the proving part. Let us see how we will prove it. I think this, since it contains root, we have to eliminate root by rationalizing the denominator. First step, we have to rationalize. Okay, we are given tan inverse root 1 plus x root 1 minus x by root 1 plus x. Okay, so we have to rationalize. What is the rationalizing factor? Root 1 plus x minus root 1 minus x root 1 plus x minus root 1 minus x. So we can look the denominator, we can see both are identical expressions. So both are same. So we have a minus b, we can express like that, a minus b whole square, because they are identical expressions, minus sign in the middle. So we will apply a minus b whole square. Denominator also identical, but one is plus, another is minus. So a plus b, a minus b. What is a plus b, a minus b? A square minus b square. So it implies tan inverse bracket a square minus b square, what? A minus b whole square, what? A square plus b square minus 2ab. A square means root will be removed. Root 1 plus x means square 1 plus x only, plus b square means there also root removed, minus 2 root ab. Ab means 1 plus x, 1 minus x, what? 1 square minus a square minus b square. The denominator root will remove, 1 plus x minus 1 minus, oh, okay. So now we have to simplify for next step. Next step, simply it can, x is cut, 2 minus 2 bracket root of 1 minus x square by, here also 1 is cut. So x 2x implies tan inverse, the bracket again to take 2 common outside. Okay, taking 2 common outside, 1 minus root of 1 minus x square by 2x. 2 can be cut. It implies tan inverse root of tan inverse 1 minus root of 1 minus x square by x. So we have our proving part is this one. Still need some simplification. For further simplification, we have to do some substitution. We are taking x by sine theta. Okay, let x is equal to sine theta. So it becomes tan inverse 1 minus root of 1 minus sin square theta by sin theta. Okay, it implies tan inverse bracket. What is 1 minus sin square theta? What is 1 minus sin square theta? Cos square theta. Root to cos square theta become cos theta only. Root to cos square theta becomes cos theta only by sin theta. Okay. Now we know that in the previous question we have done 1 minus cos theta. We have one formula. What is 1 minus cos 2 theta? 2 sin square. We have 2. We have 1 minus cos theta become 2 sin square theta by 2. Sin 2 theta, sin x means 2 sin theta by 2. Already we studied this. 2 cut, 1 sin also cut. It becomes tan inverse sin theta by cos theta by 2 become tan theta by sin theta by 2. Cos theta by 2 divide, it becomes tan theta by 2. It implies theta by 2. So theta can be substituted by sin inverse x. Theta can be substituted by sin inverse x by 2. So sin inverse x can be written what? Pi by 2 minus cos inverse x by 2. So this become pi by 4 minus 1 by 2. You understand, no? Sin inverse x can be written pi by 2 minus cos inverse x. So 2 is the denominator. Pi by 2 divided by 2 become pi by 4 minus 1 by 2 cos inverse x. This is what we have to prove. Supposed to prove. Clear? Okay, we have the last question. Prove that cot inverse root 1 plus sin x plus root 1 minus sin x by root 1 plus sin x minus root 1 minus sin x is equal to x by 2. We have to prove it x by 2. So to do this question, we have some substitution, not like a rationalizing. So what will do be done? We should learn that. So actually cos x by 2 plus sin x by 2 expansion only, a whole square only actually we can 1 plus sin x. Okay, 1 plus sin x is actually the expansion of cos x by 2 plus sin x by 2 whole square. If 1 minus sin x actually cos x by 2 minus sin x by 2 whole square only 1 minus sin x. You should remember this one. So we do by substitution method. So cot inverse bracket root inside the root. So 1 plus sin x will become cos x by 2 plus sin x by 2 whole square. 1 minus sin x becomes cos x by 2 minus sin x by 2 whole square whole divided by, again 1 plus sin x become cos x by 2 plus sin x by 2 whole square minus 1 minus sin x can be substituted by cos x by 2 minus sin x by 2 whole square. So this is a square number, so root will eliminate. Root will be eliminated. So we have cos x by 2 plus sin x by 2 minus plus this also square number, so root will eliminate. Okay, root will be eliminated. Like that, in the denominator also cos x by 2 plus sin x by 2 minus sin is there. This will become cos x by 2 minus sin x by 2. For next simplification, we are getting, so we know that this sin x by 2 will be cut. It becomes 2 cos x by 2. This step part will be cut. Cos x by 2 will be cut. So sin x by 2, sin x by 2 become 2 sin x by 2. 2 is cut. So it implies we are going to get the answer. Cot inverse cot x by 2. Okay, we have some property we remember. You remember that cot inverse cot become x by 2. That is what we want to prove. Hence it is proved. We got the answer x by 2. Okay, we have so far we have discussed almost 12 questions. All the questions very very important. Hope you will practice it thoroughly. Thank you.